Hello everyone, my name is Diparanjan Das. I am pursuing BSc Honors in Data Science and AI from IIT Guwahati. Today I will be presenting my Term 2 project titled Waste Segregation Using Deep Learning. First, we will look into the agenda of this project. In this presentation, I will cover the introduction, problem context, tools and technologies that I have used, dataset that I have used, source code, outputs and results. Then we'll look into the evaluation metrics and finally the summary. So starting with the introduction, waste management is a major challenge today, mainly because of improper waste segregation and inefficient manual sorting. In this project, I developed an AI-based system that can classify waste images into different categories using MobileNet View 2. The system also provides confidence scores and recycling advice, and it is integrated with a Flask API and a Streamlit dashboard for real-time interaction. Overall, this project shows how AI can help improve waste management and make it more efficient. Next, we will look into the problem on which I have worked. So the main problem here is improper waste segregation, which affects both the environment and recycling efficiency. Manual sorting is slow and often inaccurate, especially when dealing with large amounts of waste. Another challenge is that waste images vary a lot in terms of lighting, background, and quality. Also, some categories like paper and cardboard look very similar, which makes classification difficult. So the model needs to generalize well to handle real-world conditions. Next is the tools and technologies that I have used. For this project, I use Python as the main programming language. For deep learning, I use TensorFlow and Keras. Flask is used to build the API for handling predictions and Streamlit to create the dashboard. OpenCV and Pillow is used for image processing tasks. For numerical computation, NumPy is used, and I have also used Matplotlib for visualization. Now, let's look into the dataset that I have used. The dataset was collected from Kaggle and contains more than 400 images per category. It includes different classes like cardboard, glass, metal, organic, paper, plastic, and trash. Before training, I resized the images to 224 by 224 pixels, normalized them, and applied data augmentation techniques like rotation and flipping. These steps help improve model performance and generalization. Next, we will look into the source code. Now I will be switching to my VS editor to show you the source code. So first is the model training code. So here I worked on training the model. I used TensorFlow and MobileNet V2. For the dataset, I loaded images using a tool called image data generator. At this stage, I also applied pre-processing like resizing all images to 224 by 224 pixels and normalizing them. I also use data augmentation techniques like rotation, zoom, and flipping so that model can learn better and not depend on only one type of image. Then I added a final classification layer to the model and trained it using categorical cross entropy loss, which helps measure how well the prediction match the actual levels. Finally, after training, I saved the model and also stored the class labels in a JSON file so that I can use them for later for prediction. After training the model, the next step was to create a backend using Flask so that the model can be used in real time. In this part, I first loaded the trained train model, and class mapping file. Then I created a function that takes image as input, preprocess it using OpenCV, resizes it, normalizes it, and then sends it to the model to get a prediction. The API returns three main things: the predicted class, the confidence score, and recycling advice based on the category. For example, if the output is plastic, it will suggest putting it in a recycle bin. I also added an extra feature to track how many times each class is predicted. So basically, this Flask API acts as a bridge between the model and the user interface. Finally, I built the user interface using Streamlit to make the system easy to use. Here I created a dashboard where users can simply upload an image. Once the image is uploaded, it is processed and passed to the train model. The dashboard then shows the predicted category, the confidence score, and recycling advice. I also added bar chart that shows the probability of each class so users can see how confident the model is for each category. Apart from that, the dashboard also has sections like home, inside page, and about page to give more information about the project. Overall, this makes the system interactive and user friendly, so anyone can use it without needing technical knowledge. Now we'll look into the outputs and results. So let me run dash, this dashboard using the command streamlit run dashboard.py. So here you can see the dashboard that I've created. In the left hand side, you can navigate from home, classifier, insights, and about. So these are the four pages that I have created. So in the classifier section, you can see there is an option to upload and classify. So here I can take an example. So let me upload a file. For example, this file. So once I upload it, so it will provide me the prediction that it is a metal. It will also provide the confidence score that 0.99. The model is 0.99 confident about the prediction, and it will also provide the recycling advice that put it in a recycle bin. So here is the one of the result. Moving forward, now we will look into the evaluation matrix. So the evaluation matrix that I have used is accuracy and prediction confidence. Accuracy tells us how many predictions are correct, while confidence indicates how sure the model is. The model performs well on distinct materials like glass, plastic, and organic waste. Now we'll move forward to the summary of this project. To summarize, this project demonstrates how AI can automate waste classification using deep learning. The system integrates a trained model, API, and a dashboard to provide real-time predictions. I also observed that the model performs better when the dataset is balanced and images are clearer, and data augmentation helps in improving generalization. The key takeaway is that I have gained practical experience in deep learning, deployment, and solving real-world environmental challenges. As future work, I plan to improve accuracy using advanced models like EfficientNet, also increase the dataset size and deploy this system as a real-world application. At last, you can find the detailed source code uh, using this GitHub URL. That's all from my end. Thank you for watching.